Dip switch is nothing but a throw switch only, but it will be a set of throw switches. Okay, so it's going to be something like this. You will have multiple switches like this. Together. So each of them can be independently turned on or turned off. Like this, there are multiple switches. So each one can be independently turned on or turned off. Okay, that is what is a dip switch. Okay, so this will be very much essential for you to do understand and do your lab. And one more in walkthrough tool, to simulate the bulb, right? Because we saw multiple examples about switching on the bulb, switching off the bulb, all those things. So we don't have a bulb in the walkthrough tool, so we will be using LED in place of a bulb. LED stands for light emitting diode. Okay, light emitting diode. That's what is a LED. Okay, so in walkthrough tool, symbolical electronic, in terms of electronics, the symbol of a diode is like this. In the walkthrough tool, the diode will be looking like this. You will see like this, and one leg will be like this, and one leg will be straight. Okay, so the diode is direction sensitive. Okay, so the symbol of the diode itself is like this. It means it is direction sensitive. Okay. See, if a normal bulb is there, right? In case of a normal bulb, okay, I want you guys to understand. If I connect the battery like this, or I take the bulb and connect the battery like this, kindly observe the polarity is different. So in this case, the current flows like this. Current always flows from high potential to low potential, correct? We have discussed. So current will flow like this. In this case, the current will flow like this. In both the cases, the bulb will glow. The bulb will be glowing, okay? Whereas in case of LED, it's not like that. Because LED is direction sensitive. That's why the symbol of the diode itself is like this. So it allows the current to flow from this direction to this direction. That's what the arrow in this direction is signifying. But if you come from here to here, in this direction, the diode will not allow the current to flow. So in terms of electronics, I will not go into much details. It's called as a unidirectional device. It will allow current to flow only from here to here. In the reverse direction, the current cannot flow. In this direction, current cannot flow. To represent that symbolically only, if you see, when I go from here to here, you see the arrow. That means it allows. But if I try to come from here, it blocks. That's what is the symbol of the diode itself is telling you. If you come from here, you are blocked. If you come from here, you see the arrow, you are allowed. Okay? That means if I take a battery and connect a diode like this, it will allow the current to flow like this. Correct? But if I take a diode and if I take a battery and connect like this, from here to here, current cannot flow. So in this case, even though you have connected the diode will be off. Here the diode will be on, because though the diode is just like a LED is just like a bulb, in the sense when you turn on the light will glow on the LED. It is different from bulb because it is going to, it's a normal bulb is an electrical device, LED is an electronic device. Okay, this is an electronic device. It will allow the current to flow only in one direction. That's why it's called as a unidirectional device. So we need to be careful while we are connecting this LED in the lab. So this terminal, I'll just introduce you to some terminologies here. This terminal of the diode is called as the anode, and this terminal of the diode is called as the cathode. So if you see in walk V, you will see the LED like this. One leg of the LED will be twisted little bit like this, and one leg will be straight. So this is your anode, and this is the cathode. So the anode should always be connected to the positive plate of the battery. This will be denoted in your walk V tool as VCC. And this cathode should always be connected to ground for the LED to glow. Okay, this is very, very important. Okay. So we will use this, we will keep all these points, whatever we discussed here, in mind to do our lab. Okay. Thank you.